It's very possible to filter inside of OSPF. I will say it's definitely the hardest routing protocol to do filtering, competing with ISIS. Like BGP is a piece of cake for route filtering. You think, well, BGP is super complex, but it's built for it. EIGRP, it's very, very natural. RIP, it's very natural. But OSPF wants all of the routing information inside of an area to be consistent. And for this reason, it gives us extra barriers, and we have to be mindful of those. Generally, you want to do filtering on the key routers like area border routers. But let's say you're certain. You wouldn't check route filtering unless you were certain that it was being initiated and advertised by the source router. So my order of thought would be, okay, I don't see this particular network. So I'm going to go to the router in question, and I'm going to make sure it's enabled on the interface. Then, if I'm confident that it's enabled on the interface, I'm going to look elsewhere. I'm going to look for other routers, maybe in the same area, to make sure it's being advertised. And if I see that, then I can be confident that really the only way that it's going to be removed, extricated, redacted from the routing advertisements is if it was being filtered. And that's a good leap of faith. That's a good conclusion to have if you're certain that it is being advertised and that neighborships exist. So what are you going to do? Well, you can do things like show IP protocols. And if you see some filtering, you might dig deeper in things like show access list. So route filtering for most routing protocols is possible with distribute list. There are certainly other ways of doing filtering for protocols like BGP. And a distribute list references an access control list. And we like to use standard access lists for this purpose because we only want one network specified, or we just want a network and a prefix specified. And you would look at the access list that it's tied to and make sure it's being permitted. So if you see filtering, let's say you're in the exam and you recognize that there's filtering going on, that should trigger warnings for you if you're troubleshooting this. And you're going to look at the access list thinking, is it being permitted? If it's being permitted, what will then happen is we will allow it. If it's denied, it will be removed. So just like you would expect, permit, allow, deny, remove. And if there's a deny statement that is messing you up, you would want to remove it. If you need to put in a permit, you can. And remember that access lists can be affected with sequence numbers. You can get into named access list configuration mode, and you can specify the sequence. So let's do this together. So let us say, and let's go on R3, and I'm going to do a show IP route, OSPF. Okay, so let's say I want to filter that one. I'm going to do access list 10.11.64. And I don't want to do it here, and I have to specify an access list number. We're going to say IP access list standard. To get into named, you do IP access list, choose standard or extended, and then say filter .64. And I'm just going to set up a deny. Actually, I am going to deny that one. It's a little different than the scenario I described. I just want you to see this. So we're going to say distribute list. So you can see that'll take effect. I remove the .64, and if I wanted to permit that, let's do a show IP access lists. I see the deny for that. So if I want to, let's say this was a more generic statement and I had to preserve it, I would need to know how to affect that. So I'm going to do IP access. IP access list standard filter .64, and then I can say 5 permit, and I could say the same thing, 10.1.64. And we're getting it once again. So know how to affect your access control lists if they are involved in route filtering, in the case where route filtering is harming your connectivity inside of your routing domain. Now there's one other thing that I want to show you, and that is you can also filter by setting the administrative distance to 255 for routes. So this syntax would say, set the administrative distance to 255 for routes coming from this router ID of 1111. So maybe in a lab, that's router 1, with a wildcard mask that pins it down to just that one IP address, and you can tack on a routing filter. So this would be a real problem if you saw that. That also should trigger some warning signs. That's a filter. It doesn't look like a filter, but it is. So let's say do show IP OSPF interface. No, neighbor. I want to get some router IDs, and I want to say what's my neighbor. Okay, so say I want to drop all of those routes from these two. So I'm going to say distance 255, 192, so what I just did is I said anything that has 192 for the first octet, wildcard out second, third, fourth, is going to be filtered. Let's see if this takes effect. Okay, looks there. And let's go to R4. Let's see if that got removed. Seeing those. Just want to make sure that my syntax is good. Set the administrative distance to 255 for 192. 0, 255, 255. That looks good. I have my neighborships. Do show IP OSPF neighbor. Let's look at router 4. Okay. So this is a problem. Router 3 is essentially doing filtering at this point. Let's remove it. Let's remove that distance command. I had to clear it out. See how quickly that'll get fixed. There we go. So we fixed it. Just be forewarned that that distance command doesn't look like a traditional filter, but nonetheless, it absolutely can do filtering for your own environment.